Alright guys, I am going to continue showing you through this section 3 for chapter 5 homework. So far we've gotten through strontium chloride. Now I'm going to do copper bromide. If you look at your periodic table, remember we're going to first have copper because that will be always the same using ionic compounds. Now we're going to look down at our periodic table and find copper. We realize it's number 29, so it is in a transition metal, so we have to put a parenthesis behind it to place the charge. Okay, because remember, copper could have a positive 2 or a positive 3 charge, so we need to specify which copper we have. Now we're going to type bromide in here because we know that that will be the ending. What we need to find out now is what is this charge on copper. So the way we figure it out is by looking at the other element. Because if we know what this charge is, then we can figure out what copper's charge is. Because when you add these two charges together, you must get 0. So we look at bromide on the periodic table. So you find bromide on your periodic table. Once you find it, copper, bromide. Okay. And now what we're going to do is we're going to figure out this charge on bromide. So bromide is down here in group 17 or 7A. Okay, that means that it is obviously a nonmetal. All right, and so the charge, if it's in group 7A, is a -1. Because what's going to happen is it's going to want to gain 1 valence electron, giving it a -1 charge. Here. Remember, the number up here is just telling us the charge on each one individual atom. This number tells us how many atoms are present. So that Br2 with a -1 is like saying you have Br with a negative charge and Br with a negative charge. I do not know why I put a 1 over there. Remember, you don't put 1s. It is just understood if there's nothing there that that's a 1. Okay, so if you've got 2 of them with a -1 charge, your overall charge then is -2. Now you ask yourself, what do you need to add to -2 to get 0? You add 2. So copper has a positive 2 charge. So that tells you that you put a number 2 Roman numeral in parentheses behind copper to tell everybody that that is the copper that has a positive 2 charge. Alright, so that was anionic compounds, and now we're going to name covalent compounds. Remember, naming covalent compounds is the easier one. Just because you don't need to do anything with the charges, you just need to add the prefix. So as long as you have the prefix in front of you, that's pretty easy. So lithium, because there is no prefix, the only time in a covalent compound there won't be a prefix is if the first one has only 1 atom present. The symbol for lithium is capital L, little I. Oh, this is telling us that this is an ionic. I thought this was all covalent. So you're going to write Li and then O. What you need to figure out, because it is ionic, right here, is figure out the charges. So if I write Li and O, now I need to figure out what the charges are here. So first step, again, because it's ionic, is looking at lithium on your periodic table. When you find lithium, you notice that lithium is in group 1. It's number 3 in your periodic table. So if it is group 1, that tells you that there is 1 valence electron. So it's going to want to lose that 1 and have a positive 1 charge. Remember, metals are always positive, non-metals are always negative. And then oxygen, we know it's going to be negative, but how much negative? So oxygen is in group 6A, so it's going to want to gain 2 electrons, which will give it a 2- charge. So it's a -2 charge. So, because oxygen has a -2 charge, and lithium has a positive 1 charge, now what you're going to say is how many lithiums with a positive 1 charge do I need to balance out this -2 charge? So this is -2. You want your result to be 0. So how many of these do you need? Well, the only number you want to get is 2. Because 2 minus 2 is 0. So Remember, this is an understood 1. So 1 times what gets you 2? 1 times 2 gives you 2. You will write a 2 in subscript. So your final answer then is Li, the shift dash underscore. There are 2 lithium atoms compared to 1 oxygen atom. Now carbon monoxide, this is covalent, so this is the one where it's going to be easier. Carbon, because it's a covalent, first one only has 1 when you just say carbon. If it had more than 1 atom, there would be a prefix like di or tri or tetra saying how many atoms there were. Now the second one, we know it's oxygen, and we know there's only 1 because the prefix mono means 1. So carbon monoxide is written like that. Now this one is carbon tetrachloride. It is also a covalent compound. Within carbon, there's only 1 because there's no prefix. Tetra, if you look at your prefixes, you know that there must be 4 of the chloride. Cl underscore 4. Again, because tetra tells you, that prefix tells you there are 4 chlorides. So there's 4 chlorine atoms. Carbon, there was no prefix, so there was only 1, so you don't write anything. Now nitrogen is a capital N. There's no prefix, so it tells us that there's only 1. Now fluoride is trifluoride, and tri, 3. So there are 3 atoms of fluoride. Now calcium, Ca is the symbol. Again, this time, it does not tell you if it's ionic or covalent. So I'm just going to write calcium and chloride, and then I'm going to figure it out. So calcium, and on the periodic table, here it is. That makes it a metal, and we know the charge. So I'm going to write it over here. This makes this an ionic bond, so I have to deal with the charges. I'm going to first write Ca, Cl. I need to figure out how many atoms of each of these do I need to neutralize the charge. So calcium has what charge? Looking at the periodic table, it has 2 valence electrons that it's going to want to lose. So it's going to have a +2 charge. Chlorine, if you look at the periodic table, is in group 7. It's going to gain 1 electron, so it has a -1 charge. Therefore, we know in order for this to balance out, so you have a +2. You're going to add 1 times what equals 0. So you're going to go 2 plus 2, right? Because that's what, 2 plus -2, because of course this is the negative. 2 plus -2 is what gives you 0. So 1 times 2, you need 2 chlorine atoms to balance out that +2 charge. Again, it's because you want your overall charge to be 0. And this is like saying you've got 1 Cl with a negative, plus another Cl with a negative. There's 2 negatively charged put together, which balances out that one. A +2. Therefore, the final answer will be CaCl shift underscore. This portion, remember that this explains the difference between an iron nitrate and an iron 3 nitrate. Remember the difference here is that the charge of the first one is +2 and the charge of the second one is +3. Molecular is how many atoms are present, and empirical tells you the lowest whole number ratio of atoms present. All right, hope that answered any questions. Remember to come see me before or after school, or schedule a time during any class period to come see me. Thanks.